Okay. Hi, everybody. This is Julia Mills, and I have the great honor to have on this call today my dear friend and mentor, Dr. Jeffry Life. I'm going to take a few minutes to read his biography and his incredible accomplished life that he's had in medicine. So I'm going to read his biography, and then he is going to actually share with us a presentation that he gave at the AMMG conference in Dallas recently. So thank you for being here today. I'm going to start off. Dr. Life is the 2007 recipient of the first AMMG Alan P. Mintz MD Award for Clinical Excellence in Age Management Medicine. He was the former Chief Medical Officer of Cenegenics Medical Institute and ended his association with Cenegenics on March 1st, 2014. Dr. Life is board certified in family medicine and is a diplomat of the American Board of Family Practice and a fellow of the American Academy of Family Physicians. After receiving his medical degree from the University of Iowa, Dr. Life completed his residency in family medicine and internal medicine at West Virginia University. He also attained a Ph.D. in environmental sciences and health at the University of Michigan. During his career, he was a full-time family physician and a part-time assistant professor at Marywood University in Pennsylvania, teaching graduate courses in nutritional science and exercise physiology. In 1998, after reaching a lifetime high in body weight, percentage of body fat, and level of deconditioning, Dr. Life entered the EAS National Body for Life Challenge at age 60. He became a grand champion and has continued to live a lifestyle promoting health and fitness. His book, The Life Plan, was released in 2011 and became a New York Times bestseller. His second book, Mastering the Life Plan, was released in March of 2013, and his third book, The Life Plan Diet, was released in 2014. Men's Fitness magazine selected him among movie stars and athletes in their 20s and 30s as one of the 25 fittest guys in 2012 when he was 74 years old. He has appeared on Inside Edition, The Dr. Phil Show, The Doctors, Anderson Cooper's AC 360, and The Steve Harvey Show. You can visit his website to learn more at drlife.com. Since early 2015, he has resided in Charleston, West Virginia, and continues to practice healthy aging medicine with a focus on heart attack and stroke prevention at his clinic, the Life Center for Healthy Aging. So without further ado, we are in for a treat from one of the most accomplished physicians on age management medicine and healthy aging. So thank you, Dr. Life, for being here today, and we're really excited to learn from you.
Thank you, Julia. It's good to be here. I'm going to give you my talk on sarcopenia, which I presented just a little over a week ago at the Age Management Medicine Conference, Age Management Medicine Group Conference in Dallas, Texas.
Excellent.
So with that said, I'm going to get into this. So let me hopefully. And I had to tell them, my audience, that I had no relevant relationships with a commercial interest to disclose. And my introduction to sarcopenia really started 30 years ago in 1991, when this book, Biomarkers, written by William Evans and Erwin Rosenberg, came out. They published this book in 1991 on biomarkers, and they talk about the 10 determinants of aging that you can control. So I got that book and started reading it, and I was just really intrigued by it all. The 10 key biomarkers of the aging process are in order of importance: muscle mass, strength, BMR, percent body fat, aerobic capacity, blood sugar tolerance, cholesterol levels, blood pressure, bone density, and our ability to regulate our body temperature. They point out in this book that muscle mass and strength are the two most important variables determining the quality of your life. 3 years prior to this, Erwin Rosenberg made this statement in a speech or something he published. He said, no decline with age is more dramatic or potentially more functionally significant than the decline in lean body mass. And he questioned, why have we not given it more attention? And he posed this question, perhaps we need to name it. And he picked out two names from Greek sources. He says, I'll suggest a couple, sarcomalacia or sarcopenia. And this was in 1989. But we know sarcopenia is the one that took hold. And so he is the creator of that term. I would say the father of sarcopenia. And with that, I'm going to introduce all of you to sarcopenia. What's it all about? It's a Greek term, as I said, for poverty of flesh. It refers to the age-related insidious loss of muscle mass and strength as people age, as healthy people age. It's defined as having a lean body mass of greater than 2 standard deviations below the young normal mean. And it starts at the beginning of the 4th decade of life. In other words, when men and women enter their 30s. It progresses at the rate of 3 to 5% for the first decade. Then it increases to 10 to 20% per decade after age 50. It involves mostly type 2 muscle fibers. These are the fast twitch muscle fibers. And this results in a dominance of the slow twitch muscle fibers. And this results in a decrease in force generating capacity. In other words, a loss of strength. I thought it'd be interesting for everyone to review the different generations. We got the greatest generation. Those folks are now 94 to 100 years old. We've got the silent generation, also called the silents. And that's my generation. I was born in 1938. And these folks are 76 to 93 years old. Then we have a large baby boomer generation. These individuals are 57 to 75. Then we have Generation X or Gen X. They're 41 to 56. Then we have the millennials, 25 to 40 years old. And then Generation Z, age 6 to 24. And our new generation called the Alpha generation. And these are people that were born in the early 2010s to the mid 2020s. Baby boomers, 78 million baby boomers began turning 65 in 2011. And then from that time on, from that time until 2030, 10,000 boomers will be turning 65 every day. And here I have a picture of a bunch of baby boomers, 65. And I'm not sure what they're celebrating. Maybe they're celebrating the fact that they're on Medicare now, or maybe they're looking at their grandkids. I'm not sure. Here's some facts. The average American adult can expect to gain approximately 1 pound of body fat every year between the ages of 30 to 60 and lose about half a pound of muscle mass each year over that same period of time. And from age 60 on, it gets even worse. The average 25-year-old male is 20% body fat. By the time the average 25-year-old reaches age 55 years old, 30% body fat, then 75, greater than 35% body fat, and then 85, greater than 38% body fat. So what's the potential impact of aging? Significant loss of muscle mass and strength have occurred by the beginning of the 5th decade of life. In other words, when people enter their 40s. Body fat increases, especially visceral fat. I pointed out that body mass index can be very deceiving. You can have a BMI that's considered normal, but if a man has greater than 20% body fat, he is now considered to be normal weight obese. And same with women that are 30%, greater than 30% body fat. And the only way that can happen is if you lose muscle mass and maintain a BMI that's considered to be healthy and you have a lot of body fat. You got to have very little muscle mass. And as muscle mass is lost, energy levels decline and frailty begins to ensue. The activities of daily living begin to become compromised, and our quality of life diminishes. Longevity is decreased. Nursing home admissions become a necessity, and healthcare costs skyrocket. The largest loss of muscle mass occurs between age 50 and 75. And here we have two happy-looking, very cheerful 50-year-olds. And they're happy because maybe they don't know that they're going to be losing 25% of their body fat over the next 25 years. Or maybe they know they are and they're doing things to stop it. 24% of men and women that are less than 70 years old are sarcopenic. And greater than 50% of men and women age 80 are sarcopenic. The direct consequences of sarcopenia: loss of muscle mass and strength, results in a decrease in BMR, decrease in growth hormone production, decrease in testosterone production, increase in cortisol and cytokines, loss of neuromuscular function, increase in visceral adiposity, and an increased risk for age-related disease. An increase in the perception of exercise effort, and this results in an exercise avoidance, followed by physical inactivity and deconditioning, and a worsening of mitochondrial dysfunction. And this is the key part of my talk: mitochondrial dysfunction or mitochondrial health. That is also associated with a decrease in cardiac output, an increase in the incidence and progression of chronic diseases, all of them, increase in the risk for developing metabolic syndrome, predictor of poor medical and surgical outcomes, and increase in postoperative complications, especially infections. This all accompanies our loss of muscle mass. Also, we see a decrease in VO2 max, and an increase in risk for falling and fractures, and a significant amount of morbidity. Activities of daily living become compromised, and nursing home placement becomes a necessity. Our inability to perform activities of daily living because of frailty or sarcopenia is the #1 reason people end up in nursing homes. That to me is shocking. The elderly population, those people that are 65 years of age and older, is expected to double in the United States within the next 25 years. And sarcopenia will become an even greater burden for our society unless we can stop it. I point out that our healthcare system is totally out of control, and this picture really epitomizes being totally out of control. In 2019, our spending on health, and I put my own little word in there, disease, it's really about disease, accounted for 17% of America's gross domestic product. By the middle of this century, in about 30 more years, spending on Medicare alone will consume an estimated 40% of the total US budget. We must eliminate sarcopenia and chronic diseases to avoid this disaster. The direct healthcare cost attributed to sarcopenia in the United States in 2000 was $18.5 billion. 10.8 of that was from men, 7.7 from women. If we could reduce just by 10% our incidence of sarcopenia, it would result in a savings of $1.1 billion per year in the healthcare, the US healthcare costs. 1.1 billion if we just drop sarcopenia by 10%. Sarcopenia is a totally preventable disease. What are the causes of sarcopenia? Protein metabolism, a decreased or diminished rate of protein synthesis in older adults. Hormones, decline in anabolic hormones with aging, testosterone, growth hormone, DHEAS, and estrogen. Neuromuscular changes, age-related declines in functioning spinal cord motor neurons and motor units. Physical inactivity, lack of activities that overload the skeletal muscle system. specifically resistance exercises. Nutrition, inadequate intake of protein, other nutrients, and antioxidants. And last but certainly not least is mitochondrial dysfunction. Diminished ATP production in the mitochondria as a result of damage to its DNA. And here's a mitochondria. It's the powerhouses of our cells. These are little tiny cell organelles that contain the principal site where 95% of all of our energy that powers all living things is created. And I have a picture here showing the cristae and the DNA, and this is where ATP is created, generated. Here's some interesting mitochondrial facts. Muscle cells have a high energy demand and contain large numbers of mitochondria to maximize ATP production. Our cardiac muscle cells contain the largest number of mitochondria. And another really interesting fact is we get all of our mitochondria from our moms. So wish your mom a happy birthday on Mother's Day. Not a happy birthday, but just wish her a happy Mother's Day and thank her for your mitochondria. Oxidative phosphorylation. This is the conversion of energy from the foods we eat to the high energy phosphate bonds of ATP. This occurs in our mitochondria. It's also known as the Krebs cycle or the citric acid cycle, and it's a source of 95% of our energy. Reactive oxygen species. These are dangerous atoms or molecules containing one or more unpaired electrons that are formed during the normal metabolism of oxygen as a result of oxidative phosphorylation. There are also some exogenous sources that contribute to reactive oxygen species. Reactive oxygen species are necessary in very small amounts, but in large amounts, they attack and destroy proteins, enzymes, cell membranes, and mitochondrial DNA. This brings us to the mitochondrial theory of aging, and it was formerly called the free radical theory of aging from reactive oxygen species. This was changed to mitochondrial theory of aging when it was discovered that most free radicals are produced in the mitochondria during oxidative phosphorylation. Sarcopenia is now thought to be primarily caused by free radical damage, oxidative stress to the DNA of our mitochondria. It's the main cause. So this brings me to mitochondrial heteroplasmy, which is simply a word that describes the different types of DNA. And there are only two, really, only two: damaged mitochondrial DNA and wild type or normal mitochondrial DNA. And when our damaged DNA reaches 80% or greater, that's when cell function becomes disturbed. And this results in muscles beginning to atrophy and sarcopenia developing. So I had my artist friend draw me a picture of a dysfunctional mitochondria. And you can see there's no ATP in this poor, pathetic mitochondrion. And it's all burned out. It's got a lot of damage. He's got Band-Aids on it, his head and his knee. And this is a dysfunctional mitochondrion. So the question has been posed over some period of time. Can resistance training interfere with the key aspects of the free radical theory of aging and prevent sarcopenia? Well, we don't know the answer for sure, but what we do know is that regular resistance training can induce adaptations that directly slow the progression of the mitochondrial theory of aging. Resistance training can significantly increase type 2 fiber cross-sectional areas. In other words, it can increase muscle mass in older adults. And it also can increase mitochondrial volume, the actual numbers of mitochondria. And this leads to an increase in force generating capacity, in other words, greater strength. And this increase in strength and gains in muscle mass after training will lead to improved activities of daily living and performance and quality of life. And this helps keep people out of nursing homes. But in spite of all this,